worry about in like your SOC at your large company? Probably not, but when you go home and you get on the internet there, this is probably something you might want to worry about. So why are there web services on cable modems, right? It's a good question. Port 80, like I was saying, is the informational service, which tells you like the model number, the firmware version, where you can get support information if you have a problem. And then on port 6080 or 8080 is the signal analyzer. So the interesting thing about this is cable modems generally exist outside the firewall. So that makes sense, right? You plug the Ethernet jack from your cable modem into your WAN port, and then the rest of your network plugs into the other side of your firewall or your router or whatever. So even though cable modems exist outside of the network, you can still access them from inside the network with a private IP address. So this exploit can be delivered in a couple of ways, right? So it's actually a vulnerability in the WebSocket connection on the web service running on port 8080. So any WebSocket client can connect to that from like the internal network, right? So think about a browser or a thick client WebSocket application like the Ruby Faye WebSocket library. Those kinds of things can connect to that web service and exploit this vulnerability. So that means this can be delivered by cross-site scripting, right? So like someone finds a cross-site scripting flaw in your favorite, medium website, whatever you want, and they can deliver this exploit through that cross-site scripting vulnerability, so that anyone who visits that particular website with that infection, it'll reboot it'll hit their modem and either like return a shell or just completely crash the modem and drop the internet service. So this is what the service on port 8080 looks like. It's like I said, it's just some diagnostic information. Basically, it's there to determine whether or not you can access your cable modem from the LAN. It doesn't really do much. There's not much in terms of configuration you can do here. It doesn't really accept post requests. It's just sort of an informational page. And the next one is the spectrum analyzer, which, oh great, there's messages popping up. Well, anyway, it's kind of like a live feed. You can comment on my talk while I'm doing it, right? So this is what the signal analyzer looks like. Yeah, please. This is being recorded, so nothing profane, please. I would appreciate that. I am wearing my company's T-shirt at the moment, so keep it PG-13, please. So this is what the signal analyzer looks like. So this does accept some input, right? Like you can turn it on, you can turn it off. I think you can set the ranges on certain things. So this is an application, a web application that accepts input, and the input is accepted over a WebSocket connection, and the WebSocket application server has a buffer overflow vulnerability in it, so that if you send an excessive string of characters in a specialized parameter, you will crash the cable modem, or if you have the memory addresses in the ROP chain built properly, you'll return a shell to wherever your remote C2 server is. So you might think that this is a vendor problem, but it's actually a vendor-vendor problem. So like the vulnerability exists in Broadcom reference software, which means the Broadcom builds the coax chip that handles the RF connection, and along with that, they provide the vendors they sell to reference software that contains this spectrum analyzer service, right? So it's not necessarily part of the vendor's code. Like for example, this is a surfboard modem. It's not Motorola's code or Aris's code, whoever the manufacturer is, I don't remember, but it's Broadcom's code. So the surfboard people get this from Broadcom. They don't really look at it. They just kind of assume, hey, it's not our code. It's probably been vetted somewhere else, right? So let's go ahead and just roll it into our final product without really any review. And I think that's how this happened. So this kind of begs the question of how is firmware distributed in cable modems? Like let's say that you go home tonight and you figure out you want to replace the firmware on your cable modem to protect yourself against Cablehaunt. Well, the problem is firmware for cable modems is distributed exclusively through the ISP. It's part of the DOCSIS standard. You can't actually go to the vendor website and download firmware for a cable modem. You have to wait for your ISP to get around to shipping you a new firmware version, which then is contingent upon when the vendor can get them new firmware. The good news is it seems that ISPs can configure your modem remotely so that this service is not on. And we have seen, at least in some cases, this to be true, even on Mediacom services, right? So like, we tested Brandon's cable modem, and it was an active cable modem on the Mediacom network, and they had shut down port 8080 and 6080. So Brandon's cable modem is not vulnerable to this. So don't go attack Brandon. You know, you're not going to get anywhere. They just did it. At some point, they decided we don't want to expose this service, and they remotely pushed a config down to Brandon's cable modem, and it shut off that port. And I know that it's accessible under normal circumstances because it's the same modem as right here. And then when I pressed the reset button on this modem, that service came up because I reset the firmware to the factory defaults. The factory defaults have it on by default. The good news is that as soon as I connect that to Mediacom's network, it pulls down its own config, its own firmware, and then it apparently turns off that port. So it's something that ISPs can help with. And yes. Yes, this would definitely be showdownable. You could easily, but the problem is this service is not exposed publicly. So the IP address that this is exposed on is 192.168.100.1. So that's a Class C internal private range that generally is not accessible to the whole internet. So while if it was exposed, and in some circumstances with some ISPs, especially in other countries, it is exposed and you could showdown it. Typically, as I've seen in the US, they don't expose that IP address publicly. So why would you worry about this? So in typical circumstances, like you set up rules and VLANs and all that stuff, and that exists all on your local network. But this service, this 192.168.100.1, is accessible outside of those VLANs, right? So generally, unless you have rules specifically blocking access to this IP address or this Class B network, usually you can reach this service from almost anywhere on the LAN, assuming that you use a cable modem to connect upstream. What does the signal analyzer do? We kind of went over this. It's usually used by line techs, right? So you have a problem with your cable modem, and the ISP comes out, and they start to troubleshoot it, right? Well, they can plug directly into the cable modem, and they get an IP address on that 192.168.100 network, and then they can go to the cable modem and see if there's signal coming in over the wire. That's the valid use case for this, right? And I mean, everyone can probably agree that is a valid use case. But in terms of small to medium businesses, do any of your users need to be able to access that web service running on the cable modem? Probably not. There's probably not a legitimate reason for anyone in your organization, sans maybe a network administrator, to access that web service. So I recommend in small, medium business environments or in home environments to maybe consider blocking off this network. Just writing a rule that says any traffic to that network, just drop it. So how does the exploit work? So like I said, the vulnerability is a parameter in a JSON object going over the wire in a WebSocket message. So if you just supply a long string of A's, right, as we do typically when we're looking for vulnerabilities, you'll crash the cable modem. But if you craft the input instead of putting a bunch of A's and you reference memory addresses in a very specific order, then you can actually return a shell from the cable modem to wherever you want your C2 server is, your remote service. So the people who discovered this vulnerability did that under 2 or 3 different cable modem types. And I want to make this point clear that it's one exploit will not work against another cable modem. One exploit is specific to a cable modem, ISP vendor. So there's a lot of variables here. So you can't just write one exploit that'll work against all the cable modems out there in the wild. You would have to tailor the exploit specifically to each combination of vendor, ISP, cable modem. So that's good news for defenders, right? Because really the only thing that people can do with this is just crash cable modems at this point, right? Without going through an extreme amount of work. One of the things that you would have to do to write this sort of exploit is get the firmware off of the cable modem, which is a feat in and of itself. It's not very easy to pull cable modem firmware off. I have taken this cable modem apart and looked for, JTAG, the other one I can't remember the name of, the headers that you can connect to, the UART. Yes, thank you. I'm sure that was Reed. So I just don't see them on there. They're not on there. Those headers aren't on there. So there's no way to solder on and just pull the firmware off over your serial connection. Generally, the only way you can pull firmware off a cable modem is if the ISP has configured it and misconfigured it in a way that lets the SNMP public or private string guessable or default value, and then you can try to you can turn on like telnet over SNMP and get in there and then pull it over a socket that way. You can also over SNMP enable serial connections somehow. I didn't really understand how that worked. The vendor that discovered this vulnerability figured that out and was actually able to transfer firmware images off over X modem, but their hardware must have had UART or JTAG ports on it, something where they could solder on and establish a serial connection. So how can I test if my cable modem is vulnerable? Right now there's a Metasploit module in development that's submitted as a pull request to the project that will actually go out and test your cable modem for this vulnerability. Now what happens when you run this Metasploit module? You lose the internet, so don't do it remotely, right? If you're somewhere off, on someone else's network doing a penetration test, don't run this module and knock out someone's internet without at least talking to your customer first, because they get kind of testy about that sort of thing. This module has not been merged into the main branch yet, into the main repository yet, but we're working on it. It's fully functional as it is, and I don't know of any problems with it. I just haven't gotten through the review process with Rapid7 yet. So this will get merged in eventually. It's just a matter of going through the review process, and I know they're really busy on their side, so it's just a work in progress. And I will attempt to do a live demo against this cable modem right here using this module at the end of the presentation. So knock on wood, hopefully that goes well. So how does this module work? So there's 3 steps to it, right? You can't just shoot a payload off and say, okay, it works. So you've got to be able to baseline, right? You've got to make a request out to make sure that the cable modem is accessible, and that the web service specifically that you want to attack is accessible. That's either 6080 or 8080. So you make a web request to that address. If you get a response back, the cable modem's online, and then you can attempt to send the payload to it. So the step 2 is actually opening the WebSocket connection and sending the JSON object with the long string of characters for the specific parameter, and then closing the WebSocket connection. At that point, you need to check and make sure that the cable modem is offline. So then you make a request to the same, like number 1, the same request you made in step 1, but you're expecting to not be able to connect. You're expecting a connection refused or a network unreachable error because the cable modem should have crashed if it's a vulnerable addition. This is a screenshot. You probably can't see it that well, but this shows you the JSON object over the wire that gets sent with the vulnerable parameter. The vulnerable parameter is fstarthz. So that's where you insert either the exploit payload that has the ROP chain and all the goodness that you extracted from the firmware, or the long string of characters if you're just trying to test that you are vulnerable and crash the device. So I should have put this at the very beginning. I forgot to do that. I forgot to reorder these slides. But the credit for this vulnerability goes entirely to Lyrebirds. They publicly disclosed this vulnerability in January of 2020. The website they established to kind of document their findings and document their disclosure process is cablehaunt.com. They did excellent work all around on this, and I can't praise their discovery high enough and their research high enough. They did a very good job. I believe it's at lyre_birds at Twitter if you want to follow them. Highly recommend that too. So yeah, I just want to shout out to them. That's about it. Before I take questions, I'm going to try to do this demo, and we'll just kind of see how it goes, right? And if it doesn't go well, at least it's recorded and everyone can laugh at it later. So what can you expect to see? This cable modem right here has 2 or 3 lights on it going right now. 15 to 20 seconds after I run the exploit, you're going to see the lights all go out or all flash or some pattern that is not what it's doing right now. So let's go over to the module. Let me drag this over here. This is the Metasploit module. And theoretically, all I have to do is type, oh no, I have to turn off the internet. Good thing I caught that before I embarrassed myself. Oh, I can't see the... Does anyone know the command to take down a network interface from the command line? Okay. Hold on one sec while I drag this over here. See, there's some display thing right now where I can't see the... Okay, so sudo if down w l s o. Okay, so that network interface should be down, and theoretically I should be able to run this exploit and it should work. So okay, well I'll try that if this doesn't work. Credentials were incorrect, it didn't work. So what do I need to tap, Jared? Yeah. My mouse, there it is. Okay, maybe I can just access this with guessing where that is. Okay. Okay, so I turned off Wi-Fi. Try this one more time. Well, okay, that's my luck doing a live demo. I guess I'm not going to be able to pull it off this evening. Thank you. Questions? Any questions, anybody? Yes. No, so cable modems are distinctly different than DSL modems in that when you put it, there's no way to put it in pass-through mode. So I know a lot of people do that with DSL modems where they just turn it into like a dumb bridge, and then there's no address for it anymore, right? It's just a pass-through bridge. You can't really do that with a cable modem. They will always have either an internal IP address on your network, that 192.168.100, or they'll have an internal IP address to the ISP that's usually not reachable either, that you'll never even see. So one way or another, it's going to get an IP address. Oh, hey, wait. The cable popped out. That's why this isn't working. Okay, let's give it a second to get an IP address and then try this one more time. Okay, it's all right. Knock on wood. 3rd time's the charm. You see, it is doing something. It does work. So look right here. You're going to see some magic in a few seconds. Third time's a charm. That's all I got. If there's no other questions, Brandon. I can not on stage, but yeah, I can do that for you. Yeah, no problem, man. Over here. So yeah, it seems to be only affecting DOCSIS 3.1 modems. Those are the only modems that I know of that have that frequency analyzer service on them. I haven't really looked at anything between 1 and 3.1, so I don't know what's there. But like, to the best of my knowledge, it's basically 3.0 and upward. Yeah. Oh, yeah. I mean, almost everything that's made by Motorola, Aris. The Cablehaunt.com has a full list of everything that's been actually confirmed and tested by the community. So I highly recommend looking at that. Yes, some Technicolor modems have this service and are vulnerable. One of the things I forgot to mention is that there's actually a username and password associated with the web service sometimes, and in some cases those values are not known. Like on my home Motorola modem, I was not able to run this because the credentials are unknown. So I couldn't access my own modem because I didn't know the credentials. Now they may be written on the bottom of the device, I just haven't checked. I think they have, but I haven't heard much of a response. I know that vendors are working to get this patched, and I haven't heard much of a response from anyone on it. I just haven't seen anything. Anyone else? Right back there. Okay. So the comment was that as a line tech, the gentleman had seen this frequency analyzer service on many different models, not just the 3.0 and the 3.1. So I stand corrected. Is that what you meant? Okay. Oh, okay. So it's actually a really important part of installing the modem. I didn't even know that. Yeah. Thank you. Anyone else? All right. Thank you so much for coming to my talk. Enjoy the rest of the evening.